Hello guys, just now we have calculated the torque that is required for loading the in order to raise the load. So we will see a small problem regarding that. So here is the problem: an electric motor driven power screw moves a nut in a horizontal plane against a force of 75 kilonewtons at a speed of 300 per minute. The screw has a single square thread of a 6 pitch on a major diameter of 40 The coefficient of friction at screw thread is 0.1. Estimate the power of the motor. So he is asking us to find out the power of a motor, and he has given us, so the given data is given as, 1 minute, let me concentrate on this. So the given data he has given us, first thing he has given us the force W is equal to 75 kilonewtons, that is 75 into 10 to the power of 3 newtons. And the next thing he has given us speed he has given. The speed will be around 300 per minute. Okay, so later here it is given as pitch. P is given 6 and a major diameter here is given, major dia, so that is D naught. Okay, so the D naught here is given as 40 Next he has given us coefficient of friction, that is angle between screw and nut, that is friction angle. Mu has given as 0.1 mu, or you can write it as tan phi. Okay, so next week, next he has given everything is known. So we have to calculate the power. For calculation of power, P is equal to T into omega. So omega is nothing but your angular speed. So angular speed. So the T is nothing but your torque that is required to overcome the friction. For calculating of angular speed, we have the formula omega is equal to 2 pi n by 60. Okay, so 2 pi n by 60, where we can calculate the n is nothing but, so here n is nothing but your speed, but he has given in per minute. So that's why we have to calculate in revolutions per minute. For calculating that, we have to go for speed of nut by pitch of the screw, okay. So with this we can calculate the omega. So later omega, that is angular speed. Later you have to calculate the torque. So for calculating the torque, we have the formula as, that is torque required to overcome the friction can be calculated by power into d by 2. Okay, so T is equal to power into d by 2. So the power, that is force P is nothing but your force, that is force required at the circumference of the screw is given by the circumference is given by, that is P is equal to W into tan alpha by phi. Okay, that's the formula we are having. So tan alpha plus phi, this looks like tan A plus B. So you can rearrange this formula as tan A plus B, so you can get the value of P. Okay, so you can substitute this value. So here and you can find the value of torque. one more thing is here, d value. So the d value is the pitch diameter. Okay, here he has given as the major diameter. So the pitch diameter is nothing but d naught minus p by 2. I already told you the pitch diameter is nothing but, suppose this is a screw, and if you go for, this is the major diameter. Okay, major diameter, that is d naught. Okay, so if we draw an imaginary line that indicates the area above this and area below this will be an equal one. So for square thread this is p by 2. Okay, so we will be taking as p by 2. D naught minus p by 2 will gives you the pitch diameter. Okay, pitch dia. Okay, so we can get the value of pitch diameter here. Okay, okay, this is the procedure. Now let us start the problem now. Okay, so we have the given data. So the first thing that we have to do is we have to calculate the pitch diameter. Pitch dia of screw is equal to d is equal to d naught minus p by 2. So the d naught he has given as 40 minus 6 by 2, that is 37 mm. Okay, the first thing that we have calculated. Next thing that we have to calculate is tan alpha, that is tan alpha is equal to pitch by pi into d. So the pitch value is 6 by pi into 37. So we will be getting 0.051. Okay, something. So tan alpha is equal to this one. So the next is nothing but force required. Force required at the circumference of the screw is nothing but P is equal to W tan alpha plus 5. Okay, so that can be written as W tan alpha plus tan 5 by 1 minus tan alpha into tan 5. Okay, so this is the thing. So if you substitute the load is given as, how much he has given, 75 kilonewtons, that is 75 into 10 to the power of 3, and the tan alpha we have got 0.051 plus the tan phi value that we have already known, that is mu is equal to the friction angle. Okay, 0.1 by 1 minus 0.051 into 0.1. So we can get the answer of P, that is force required. Okay, so after that, so I have got an answer of 11.38 into 10 to the power of 3. So I have got this answer. Later we have to calculate the torque required to overcome the friction, that is T is equal to P into D by 2. Okay, so the P value is here 11.38 into 10 to the power of 3 into the D value is 37 by 2. Okay, so we can get the torque value. Just calculate the value and tell me the answer. So I have got an answer of 210586. Okay, so that is in Newton mm. Okay, so around 212 or 210.0 or 210.58 Okay, that will be Newton meters. Okay, later we have to calculate the speed of this screw. Okay, so the speed of this screw is equal to speed of screw is equal to n. So it has given as meter per minute or something like that. 1 minute, let me show you. So here the speed he has given as mm per minute. We have to convert into revolutions per minute. For that we have to do speed of the nut. Speed of nut by pitch of screw. Pitch of screw, that is equal to 300 by 6. So we will be getting around 50 rpm. So this is the answer that we have got regarding the n value. Later we have to calculate the angular speed. So the angular speed is equal to omega is equal to 2 pi n by 60. That is equal to 2 pi into 50 by 60. So we will be getting around 5.236 radians per second. Okay, so later we have to calculate the power. So power is equal to T into omega. So the torque value is 210.58 into omega value is 5.236. Just calculate the value and tell me the answer. So you will be getting the answers in watts. Just convert into kilowatts. Okay, so that is the end of your problem. So later we will discuss another topic that is related to power screws. Thank you.